Hello, everybody. Now we are going to enjoy again with chemistry. And look to the title here. What do you expect to understand? Atom, molecules, and ions. How we can differentiate between all of them, right? Let us take it with examples. And again, we will take it in more understandable way than in memorizing. So let us see. If we take this example here, water will give hydrogen plus oxygen, right? So in this case, what about atoms are the building block of elements, right? It means atoms combine in different ratio to make compound, right? So the atom is the unit of an element, like this. Hydrogen is atom of the element, etc. Right? And the atoms combine in order to make a compound, of course. And the chemical reaction, it can be separation, like in this case, water give separation of hydrogen and oxygen. If we make it the opposite way, hydrogen plus oxygen, it is combination to give water, right? So what about if we talk to electron and proton, neutron? Electron means negative charge. Proton, positive charge. Neutron is neutral, so it is zero. Not positive, not negative. What about 1 AMU? 1 atomic mass unit, right, is equal 1.6. This is constant kilogram, right? What about atomic number and the mass number? How we can know about that? The number of neutron usually is atomic mass minus atomic number. But to define that, we go to take example. Look to here. Any atom has these two numbers, right? What means the down one or Z? So superscript and downscript. The down, this is the simple element, of course, in element, like hydrogen, carbon, nitrogen, oxygen, phosphor. And then the upper one, or subscript, is the mass number. What about the down now? One atomic number. So now you know it very easily, right? What about atomic number? And here you can see is a periodic table. And now you can practice on what we have said. Where is the atomic number and the mass number? You can practice, right? What about isotopes? Don't read here. Look to the examples. Hydrogen, hydrogen, hydrogen. It means we have the same atom. What about the down here? 1, 1, 1, the same. What about the atoms here? 1, 2, 3. So this is the only different. This means that the number of neutrons is the only difference between the isotopes. And that we call it isotopes. So here hydrogen have only one here. So proton, one proton and no neutrons, right? Because neutrons is a difference, right? Here we have how much in the deuterium? Now I can hear you. We have one proton, right? And the deuterium here is 2, right? So it means the mass number here is 2, right? If we get to the third one, here we have one proton, right? And The mass number is 3. What about how many neutrons? 3 minus 1 equal 2. 3 minus 1 equal 2. It means we have 2 neutrons. 2 minus 1 equal 1. We have 1 neutrons. 1 minus 1 equals 0. It means no neutrons. So now you can say what means isotopes. Atoms that have same atomic number, which is a down one, which is a proton. So atomic number is the same, but different mass number. Atomic number and the mass number. So mass number is different. So you see, when you look first, look to the symbol and then try to get the conclusion. We take another example here. What is the difference? Carbon here and carbon 13 and the carbon 14. So what is the difference here? Is isotopes. So here 6 proton, 6 neutrons, as you can see. You count them. So here 6 proton, 7 neutrons. Here 6 proton, 8 neutrons. So it means that the carbon has 3 natural isotopes with atomic weights of 12, 13, and 14. It means that they have the isotopes of 12, 13, and 14. What about the importance? Notice here, the chemical properties of element is determined by the number of protons and electrons. Thus, isotopes of element have similar chemistries, forming the same type of compounds and displaying similar reactivity. I hope now you understand the isotopes and the proton, neutrons, and electrons, right? I'm sure. If you look here, for example, this is uranium, 92, 235. Now, in this case, it is not 236, as we said before, not in sequence, but 238. So it means that they are different by 3. Of course, here, uranium, you know, it can be used in good way, it can be used in bad way as well. So this is another example to show you what is the difference between proton, neutrons, and electrons. Now you can practice of sodium as well. Now I can hear you. How many proton here? How many neutrons? How many electrons? I can hear you. 11 protons? Yes. And neutrons? 23 minus 11 is 12. What? How many electrons? Yes. 11. Right. Now you can practice with such examples and please work in group, as I usually say. What about molecules? We have explained it before about molecule and the chemical compound. Look here to the H2O. Is it molecule or compound? NH3, CH4, and all compounds are molecules, right? But what about all molecules can be compounds? Of course not. For example, the molecule like oxygen is molecule, hydrogen molecule, iodine molecule, but it is not compound. Why? Because compound must have at least 2 atoms, right? Or 2 molecules. So it must have 2 substances. So compound substance composed of 2 atoms or more different elements, right? So now you know what is the difference between both. What about, look here to the difference between both. Then you can get the conclusion, right? What about, if you look here, hydrogen, nitrogen, oxygen, chlorine, these all contain 2 atoms, right? When it is 2 atoms, then it is diatomic molecule. What about here? If you look to here, O3, H2O, NH3, CH4, means more than 2. Can we say it? Diatomic? No, because it's more than 2. Then we call it polyatomic molecules. I hope it's clear for you. What about ions? It is only atom or group of atom that has a net of positive or negative charge. Therefore, look to the examples here, right? Sodium here and sodium here. What about cation and anion? Cation, what do you expect of cation? Cation and anion. Look to the example here. Here is the sodium, right? 11, 11. What about chlor? 17, 17. But here is the protons. How many? 11 protons, 10 electrons. It means a proton is one more. That's why we have it positive. What about if it is proton 17, electrons 18? So electrons is more. 18 minus 17 is minus 1. That's why chloride has only one negative charge. Now you know why it is positive and negative, right? Therefore, ion is an atom or a group of atoms that has a net of positive or negative. Positive, it means it is cation, has a positive charge. And when it is positive, it means a neutral atom loses one or more electrons. So here, like here, for example, right? And the opposite here of anion, it means the negative charge. So the neutral atom gain one or more electron. That's why it becomes an anion. That's why if you look here, chloride was 17 electrons, but it gained one electron. So it becomes 18. That's why it becomes negative. While sodium is 11 electrons, it loses one electron. So when it loses, it becomes poor because you lose. Then it is, if you have $10 and you lose one of them, you lose, it becomes positive. So losing in chemistry, you become positive. Gaining in chemistry, it is negative, right? I think it is very easy for you now to know why sodium becomes positive, why chloride becomes negative. Here, because electrons, you lose one electron. That's why you become positive. Here, you gain one electron. From 17 electrons, you gain one. It means you become negative. So positive is poor in electrons. Negative usually is rich in electrons. That's why now you can see the ions. Monoatomic. Monoatomic. Look here. One positive. This one element, right? It contains only one atom, like potassium, fluoride, monoatomic, magnesium, aluminium, etc. So here it is only one atom. What about if you look here? Is it only one? No, it is two, like OH, CN, NH4. Then when it is more than one, it is polyatomic ions. So the ions is divided into mono and di. You can see now how we understand. What about here? Now, how many protons here? And how many electrons? And why this is 3? Can you think for a second? I can hear you. Now you know it. Proton here is 13. Right. What about electrons? 13 minus 3. Right? Because this is aluminium is 3 positive. So 13 minus 3 is equal 10. What about neutrons? 27 minus 13, as we know before. This means it is 14 neutrons. Look to selenium. Now I can hear you. How many proton and electrons are here? Proton is how many proton? 34. How many electron? Now 34 plus 2. Why? Because selenium is negative. Here was positive. So we say 13 minus 3 equal 10 electrons. Because as we said before, electrons is negative, right? Here is positive. So we call 13 minus 3. And here electron, 34 minus 2. It means plus 2 equal 36. Now you can enjoy. How many neutrons? Here, neutrons, 78 minus 34. So, right. So now you practice. That's why now we can say in chemistry, you have molecular formula and empirical formula. This is very important to know what is the difference between both. So molecular formula, it is the number of atoms of each element. But go to examples. This will explain you better to understand the text. Take an example, as I usually say, then you get the conclusion by yourself. Look here. We will take it one by one. If you take one mole of C6H12O2, this is a molecular formula, which means that each atom, each element has how many atoms here? So C6H12O2. But what is the simplest form of whole molecule of this one? So the simplest form of this one is C3H6O, half of it. What about if we take N2H4? What do you expect? It will be half of it, NH2. This is the empirical formula, right? What about if you take O3? Oh, now it is difficult, right? Because it is O3. How you can make it half? Then it is O with electrons, right? What about C2H4Cl2? Yes, CH2Cl. What about C8H10N4O4? Is C4H5N2O2. Al2O3. Now it is tricky. It is the same whole of it. Al2O3. I think now you understand what is the difference between molecular formula. Now this is the structural formula, which it showed the relative arrangement of atoms in a molecule, right? What about, so this means that it shows the exact number of atoms of each element, as I have said, in the smallest unit of substances. So six atoms of the element carbon, 12 of element hydrogen, 2 of element oxygen, right? This gives you the molecular formula. So very important for chemistry. What about its empirical formula? It is the simplest form of this molecular formula. I think now it's easy. Look for the molecular formula. Hydrogen is H2, water H2O, ammonia NH3, methane CH4. So empirical formula H2, water H2O, ammonia NH3, methane CH4. What about structural formula? Just to show the bonds. I told you before, hydrogen, only one bond, HH, one bond. Oxygen is 2 bonds, one bond here, one bond here. We already know hydrogen must be only one bond. Nitrogen, 3 bonds, 1, 2, 3, and already hydrogen is 1, right? Carbon is 4, 1, 2, 3, 4. So this are the structural formula. You can see it in another nice way. HH, 1 bond. Oxygen in red color, 1 bond here, 1 bond here. So 2 bonds. Nitrogen, 3 bonds, 1, 2, 3. Carbon, 4 bonds here. Now you can understand what means structural formula, molecular formula. If you go back to this text, now you can understand it. Is a slide I showed before. That's why I told you don't read that. But if you read it now, after you understand, then you know what means molecular formula. These molecules show the exact number of atoms of each element in the smallest unit of substance, the actual number of atoms in a molecule. What about molecular models? Ball and stick models and space filling models. What about the structural formula? It shows the atoms are bonded to one or another in the molecule, right? So that's why I say usually go to examples first and understand it. Then you talk about the text by yourself. And for a chemist, it's very important to know about hydrogen 1 bond, oxygen 2 bonds, nitrogen 3 bonds, carbon is 4 bonds. And here you can see it in very nice way. And that's why we call it ball and stick model. Right. Another way is here. You see, hydrogen, hydrogen, oxygen in red color, 2 bonds, nitrogen in blue, 3 bonds, carbon in black, 4 bonds. So you see, space filling model. This is how it look like in both models. Formula of ionic compound is, what about the formula of ionic compound and how much is equal? Go to example, as I usually say, take the easiest one, potassium bromide, one positive, one negative, equals 0, right? What about if it is calcium oxide? Calcium, Ca oxide. Calcium is 2 positive and oxygen is 2 negative, 0. Oh, now it is tricky. Aluminium oxide. Al is 3 and oxygen is 2. Now it is tricky, right? It cannot be 0. So what you will do? Oh, it must be Al2 or 3. So 2 and this is 3. It means 6 positive. Oxygen 3 and it is 2 negative. So 6 negative. 6 positive, 6 negative. It means 0. Potassium bromide, it will be the same. 1 positive, 1 negative. Magnesium is 2 positive. Nitrogen is 3 negative. Now again, tricky. It cannot be MgN because it will be 2 positive minus 3. It will not be equal 0. What you will do? Now I can hear you. It will be Mg3N2. 3 في 2 is 6 positive. 2 multiplied by 3, 6 negative. Calcium oxide, 2 positive, 2 negative. It means is the same. And here is the periodic table. Of course, you don't memorize periodic table. Usually you get it in the exam, right? What about ionic compound is? I think now you can practice, as we have said before, about positive and the negative. And the rule is that to put the name of the metal first, then non-metal. That's why we call it iod. Like, for example, now I can hear you. How we will nomenclate, how we will give the common name here. We start with chloride or sodium? No, we start with sodium because it is a metal. And then for the second name, we put iod. So we call here sodium chloride, right? Zinc, iodide, aluminium oxide, etc. You can practice on that. Potassium bromide, calcium oxide, magnesium sulfide. You see, chemistry is fun, I think. What about NH4? We call N before is 3 bonds. Now N has 4 bonds. So we must call it ammonium, IUM, right? Here is in the periodic table, positive and negative. What about here? Metal cation. Now it is tricky. The metal can have 2 types. It happens like like metal iron, right? It can be ferrous, it can be ferric, 2 positive or 3 positive. So these are exceptions like ferrous chloride, ferric chloride. And in order to avoid confusion, we call it iron 2 chloride, iron 3 chloride. Why 2? Because it is ferric, it is 2 positive. That's why it must be 2 in order, 2 positive, 2 negative. Here it is Fe 3 positive, then it must be 3 negative. That's why we call it iron 3 chloride. So you see, I think now it is clear. So we put here Roman numeral in parentheses. Why? In order to be sure you don't be confused. What about non-metal anion? It can be divided into 2 groups as well. First group is, now I can hear you, is only 1 atom. It will be monoatomic, right? What about here? Is it only 1 atom? No, Cn, OH, now I can hear you, polyatomic. So you don't memorize. Look to the compound, then you can deduce it by yourself. What about common names of the same anions, like what you study in the lab? Carbonate. So this is anion. Phosphate, sulfate, bicarbonate. You know why it is only -1? Because now you put 1 proton. When you put 1 proton, this means it is H positive. So H positive, so H positive, +1 -2 -2 equal -1. Nitrate, only -1. Sulfite, -2. So table 2, it is about nomenclature of some common monoatomic anions according to their position. Like, for example, C, carbide, Si, N, P, phosphate, O, oxide, S, sulfide, Se, selenide, etc. So this is a group 4A, 5A, 6A, 7A. So the word carbide is also used for the anion C2, 2 negative. This is the ionic compound. Now you can practice to name the compounds. Now I can hear you. What's the first one? Copper, right? And nitrate, right? So it will be copper nitrate, and it is 2. It means copper, when it is 2, copper 2 nitrate. What about this one? Huh. Potassium dihydrogen phosphate. What about this one? Ammonium, NH4 is ammonium, as we said before, and this is chlorate. So we start usually with the first one, as we have said before, right? You can also practice again with such one. What about if you have only one? Then we call it mono, right? If we have 2, it is di. 3, tri, tetra, penta, hexa, hepta, octa, nona, deca, right? So made of non-metals or non-metals plus metalloids. So the common name of the first element is named by its name. If more than one compound can be formed, then it is the same element. Use prefix. We will say some examples, then the last element. So, for example, here, you call it hydrogen iodide. What about second one? Nitrogen tri, because 3, trifluoride. Can you guess? Sulfur dioxide. Can you guess? N2Cl4, dinitrogen tetrachloride. Nitrogen dioxide. Dinitrogen monoxide. Think now you practice. What about acid? Again, when you look to the definition, look here first. HNO3. Now you can see what is the acid defined by what? It yields hydrogen when dissolved in water. Like take HCl, it yields hydrogen. It's hydrogen chloride. What about it dissolves in water, yields hydrogen and chloride, of course, for hydrochloric acid. That's why we call it HCl aqueous. And oxoacid is the acid contain oxygen. If the acid contain oxygen, then it will call it oxoacid, right? And it is another. So let us, for example, an acid here defined as any substances yields hydrogen in very simple definition, like hydrogen chloride, right? So it yields hydrogen positive and chloride negative, and it can be aqueous, as we have said. What about here is nitric acid? What's this? Sulfuric acid. So it yields, it's also nitrous acid. Also, it yields sulfuric acid. So here is nitric acid, and this is one oxygen less, then it is nitrous acid. H2SO4, sulfuric acid. If it is one oxygen less, sulfuric acid. Again, carbonic acid, etc. What about base? Base, like, for example, the salt you are using at home, sodium chloride, is base. It yields OH, sodium hydroxide, NaOH. So acid is hydrogen, but acid base is OH, right? Like sodium hydroxide, potassium hydroxide, so barium hydroxide, etc. Now you can take the conclusion about compound, right? So the compound could be ionic, could be molecular. right? Like binary compounds, and we use the mono, di, etc. Ionic, it can be cation, it can be with one charge, like this, right? And it can be cation has more than one charge, right? And we take examples of both and the naming of both of them. I hope it is really enjoyable for you. Please don't forget to put your constructive criticism and spread it for all students, because this will be good for humanity if we contribute science and if we enjoy chemistry and take it in more understandable way. Thank you very much for your listening, and see you next time. All the very best.